In this video, I'm going to show you how to get the simple regression equation or the regression equation or the regression technique using an Excel. So suppose you have X value or the one variable, other variable, this is your X variable, this is your Y variable that you can see based on your research question or the question in your examination. So suppose the question is predicting overall height from the knee height. So you know you're predicting this particular value, that is your y, because this value is dependent. So this is dependent variable from knee height, that is independent variable. So this is predicting this. So x is predicting y, or y is from x, in other words. So know what is your x, know what is your y. So in our case, this is x, this is y. So go to the data tool, go to data tab up here, go to data analysis, add in, make sure you have this added Excel, because by default it's not in the version that I used. And you can see the analysis tools, scroll all the way till you see regression. There are others as well you can explore. Click on regression. Okay, input range, you can see now here is the input y range, that's for y variable, x for x variable. Y in this case is overall height, so I'm going to select overall height. X in our case is knee height, so that's first column. I'm keeping the labels, so I'm going to click check mark labels. I can keep confidence interval or not depending on our interest, and you can click some of this if you want. I'm going to click the line fit plot for now, but you can have the other functions too. In the output range, that's where you want it to be printed. You can select it, whatever you want, and then click OK. That's it, and that's how you get the details for the regression. And you can see that the plot that I requested is also here, but I want to focus mainly on this particular statistical summary. This is based on your regression you ran for this data. Multiple R is nothing but your correlation coefficient, and you can always cross check this value is equal to what you get from this correlation analysis function, and these are two are the same things. Okay, next thing, ANOVA, you can skip it for now, but it's just for model fit, model comparison purposes. This is where the core regression things are, coefficients. You can see this is the intercept, so that's your b0 value or beta 0, and this is the b1, that's the slope for x variable, which is knee height. Other things you can find out here, p values and all those things, lower and upper confidence intervals, and that's pretty much it about regression. This is your slope, this is your intercept. The regression line is nothing but b0 plus b1x, because we have the simple linear regression here. O height, that is overall height, is nothing but 44, because our beta 0 is 44 point that value, and then b1 2.42 times x, which is our knee height. So that's the regression equation. Once you have the regression equation, you can also use it for prediction within the range. Remember, it's within the range of x values. Anything if you have any x values other than these, but within the range of, let's say, lowest being 43.5, highest being 57.7, you can certainly plug that particular number. Let's say you want to predict it for 56. So you can predict that y value for corresponding knee height being 56 by plugging the number 56 in here and getting the overall height for that. If anything is outside these values, then that's an extrapolation. Regression should not do that. That is it about the regression. And you can also take a look at the graph, and you can also fit the line and the equation for that.